radicals. What we're going to talk about in this section is simplifying perfect square roots, perfect cube roots, and perfect nth root square roots. So before we begin, we're going to take a look at a square roots, or not just square roots, but parts of a radical expression. Here we have the nth root of a. And the nth root of a, the parts of this radical expression, you have the radical sign, you have the radicand, which is the number or an expression under the radical sign, and then you have the index, in which we're calling n here. And the index is the smallest number to the left of the radical. It indicates the degree of the radical. So we're going to talk about different types of uh, indices when they are shown other than having the square root of 2. So an example with the indices, here we have the square root of 4, and here we have the cube root of 8. And the index of each of these indicates um, the degree. So here we're saying the square root of 4. Well, we're looking for a root. What will be this number that, because of the index, meaning when we square it, would give us the radicand of 4? So that number would be 2. Therefore, the square root of 4 is 2. So when we're looking at the cube root, you're saying what is that root number when we cube it will give us 8. And that number is 2. Therefore, the cube root of 8 is 2. So depending on the index determines the root, of course, but how many times you're going to be multiplying it. So here we have the fourth root of 16. You're saying, okay, what is a number that when we raise it to the fourth power or when we multiply it 4 times would give us the radicand of 16? And that is 2, because 2 times 2 times 2 times 2, or we can say 2 to the fourth power, both would give us the radicand of 16. So we're going to be looking at, of course, cube roots and square roots, but we may be looking at other roots as well. So when we're talking about square roots, we're looking for a perfect square, or that number that's under the radical sign will be a perfect square. So we have the word perfect square, which means it's a number that when it is squared, or a number is squared when it is multiplied by itself and its product is a perfect square. For example, 1 is a perfect square, 4, 9, 16, 25, 36, and we can keep going to 100. But these are some of the first couple of perfect square numbers. What makes 1 a perfect square? When we multiply 1 times 1, we have 1. What makes 4 a perfect square? 2 times 2. So you're saying 2 identical numbers, its product will yield a perfect square. as well as it doesn't have to be numbers, it can be variables. X squared, x to the fourth, x to the sixth. So when we think about multiples of 2, its product, when the power of multiple of 2, we can find the identical factor. What makes x squared a perfect square? X times x. What makes x to the fourth a perfect square? X squared times x squared. What makes x to the sixth a perfect square? X cubed times x cubed. And we can keep going. So we're looking at perfect cubes and perfect squares, but right now it's perfect square. And then we'll do a couple of examples of perfect cubes, and then the other, we may look at uh, whenever you have an index of 4, 5, 7, how do we simplify that?